Okay, so welcome to week 2. Hopefully you're enjoying your problems. We're going to actually do some sports physics this time. So we're looking at a sprinter. We've got a 65 kilogram sprinter starting from rest and accelerating at 4.20 meters per second squared. We want to find two things about him. We want to find what his net external force is, and if he does this, continues accelerating for 20 meters, and then maintains that velocity for the rest of the race, what his total time will be. So this one's kind of fun. If you like to do sports, you can think about the way that you run. We've got our givens written down. His mass is 63 kilograms. His acceleration is 4.2 meters per second squared. Starts from rest, and his total displacement is going to be 100 meters. We're assuming he's running on a straightaway. We want to know what his net force is and what the total time is. So let's get started. We know that our equation for net force is F net equals m times a. We know his mass is 63 kilograms. And we know his acceleration is 4.2. Okay, you put that in your calculator and you get that his total force is 264.6 newtons. Now we remember that a newton is a kilogram meter per second squared. And we have kilograms, meters per second squared, so we're good on that. The second part of the question asks us to calculate what his total time would be. So let's start by the first part of it. We've got to divide this up. In kinematics, you've got equations that have acceleration and then equations that don't have acceleration. So if we are assuming that he's accelerating for 20 meters, our given here will be 20 meters, and we'll look for the time it takes him to go that 20 meters. Okay? My favorite part is to eliminate the zeros. So if we know delta x, and we're looking for, we know the acceleration, we're looking for the time, we can solve this for so then we plug it in. 2. Remember that your delta x in this part is 20 divided by. Take the square root of that, put it into your calculator, and you get that his time for that first 20 is 3.08 seconds. Now we have to calculate the time that it takes him to go the rest of it. But in order to find that, we know he's not accelerating, but we need to know what his velocity is. If he's accelerated for 3.08 seconds, and we know his acceleration was 4.20 meters per second, we can use this equation to find his final velocity. We know his initial velocity was 0, so we get final velocity units cancel, and you get that the final velocity is 12.96. meters per second. That's not our final answer yet, though. What we need to know now is we need to know the time it takes him if he's traveling at a velocity of 12.96 meters per second for the rest of the 100-meter dash. The rest of the 100-meter dash is 100 minus this first 20. So use our average velocity equation, and we'll just put it right under here. That time, if you switch these, you get time is equal to delta x divided by velocity average. Okay? 80 meters divided by this into your handy dandy calculator, and you get that the time for the last 80 is 6.17 seconds. And that makes sense, right? Because this, he was accelerating the whole time, so he was going slower than this final velocity for some of it. If you add these two together, you get that, and you have to make sure you maintain in your calculator, you get his total time is 9.25 seconds. If you know anything about sprinting, you know that this guy is actually faster than the world record holder. So I hope he runs for my team, and I hope this was helpful in solving some of your kinematics equations. Thanks, and I hope you enjoyed working your next problems.